Hey everybody, this is Larry. This is me going over Q3 of the weekly contest 217 minimum moves to make array complementary. So this was a really hard problem. We're about the end of the contest, and there are only a couple of hundred of accepted solutions. So this is a very hard problem. I think the math makes it really tough. And there's some visualization. It took me a long time as well. Both during the contest, I had to come back to it. But the idea is basically, okay, for each pair, it's a little bit, convoluted, but you have each pair, right? And you could brute force what you're trying to do, each number, each sum, and there are only three possibilities, right? So given a certain sum, let's say we're trying a number for a certain sum, and we have 1, 2, 4, 3 for some reason. So the pairing is actually 1 and 3 and 2 and 4 if you want to think of it that way instead. And then now we have a limit of from 1 to limit, right? We can change each number from 1 to limit. So that means that the smallest number here, one case is noting that you can always get an answer by just changing all of them to ones, for example, right? So but that's at most going to be, the answer is going to be n, which is why I set the best to n. But then the question is trying to count the number of ways to only change one number, right? So let's look at one bucket, if you will, one pairing. So 1 and 3, right? So you have 1 and 3. What's the smallest number you can change to changing only one number? Well, that's changing the 3 to 1. So that's going to be 2. So this gives us the range of 2 to what's the max number that you can change to with changing only one number, right? Well, that's changing to 1, and that's 2 to 7, right? Oops. So that means that from 2 to 7, we only have to change one number for this thing. From 2 to 4, we do a similar math where, okay, if we change the 4 to a 1, then we get this. If we change the 2 to a 4, we get that. And what this means is that from 3 to 8, we only need to change one number, right? And what does that mean the other way around, right? That means that if you're trying to change it to, let's say you want to change this to 10, right? Well, you need to change both numbers in that case. Let's say it's possible, because then you have to change it to like 5 times 5 or something, right? So that's basically the idea about this problem. That's one of the observations about this problem. And once you kind of do this conversion for every pair, you can kind of see that they're kind of segments, and you are trying to do essentially like a line sweep algorithm from left to right, right? Because basically you could look at this as, okay, from 2 to 7, you have this number line from 2 to 7, right? Say, and then you have another number line from 3 to 8, right? And what that means is that outside of this, let's say we're trying to get this, maybe this is not a great example, but yeah. So basically outside of this, it will take 4 edits. And then once it gets to 2, it'll take 3 edits because then you could just edit the 3 and then the 1 and the 1, for example, right? Because it's outside this bound. And then once you get to 3, you have 2 edits to get to any number between that. And then here again, once this comes out, this becomes 3 edits again, and this is 4 edits, right? So basically a sweep line, you have these segments and you want to intersect them, right? So that's basically one of the core ideas for this problem. The other one is noting that, and that's pretty much roughly the hardest idea is changing it into this part. And then after that, it's just about counting the number of things after that. And for example, like this pair, the sum already goes to 4, and this sum is already go to 6. So if you want to test for 4, then you know that you actually could. This is the only other case, which is that if you want to try to sum to 4, you switch. You could make 0 edits and still switch to 4 for this pair. If you do it for 6, this pair will also be 0 instead of 1, right? So that's basically all there is. And you can actually do some. I actually didn't do it this way, but you can actually do some maps on that delta as well. Actually, that is probably a cool way of doing it, but I didn't do it that way. So yeah. So I think if I were to think about it again, so you have the total here. Okay, let me just go over the problem as I wrote it during the contest, and then I'll kind of maybe do a cleaner way of doing it, right? So basically, I set a dictionary, dictionary mapping the total to the int, and then basically essentially like a prefix sum array that basically tells you where the segment is. For example, in this case, we'll have a delta at 0.2 and 0.3 and 7 and 8. So okay, so then now for each pair, and this is just going forward each pair, so we get the max range, which is just the max of the number in that index plus the limit, or the other pair plus the limit. So for example, in this case, we either try changing the left to the limit or the right to the limit, and then the min is just switching the left to 1 or the right to 1, and that's the min, right? So that's the minimum range and that's the maximum range. The total is just the sum of the two numbers, as we said, and we keep track of the max totals just for brute forcing later on, which you'll see. So now we keep track of number of total. For that number of total, we increment 1. So for example, we keep track of number of 4s and number of 6s. For the delta array, this is basically similar to a lot of line sweep algorithms. I did it this way, but at the beginning of the segment, right, we want to subtract 1 from it, and at the end of the segment, we add 1 from it because that's the cost of doing more, right? Because now you're out of range again. Now you have to edit 1 more number. So that's the way that I did it. Current n. So now we basically start from the beginning, and we do a sweep line. We go, okay, literally, if we want all the numbers to sum to 2, what is the cost? Well, that is just the cost of what the delta is, depending on if there's a segment there. If there's no segment there, we just ignore it. Or this is 0, and then we just keep on going 1 by 1. So the delta array will allow us to kind of count the deltas from the number of segments and the boundaries, and kind of do the math on that, right? And then at the end, and that would tell us the number of edits that we need minus the number that is exactly, right? So for example, if we're looking for 4, even though it's technically in here, we want to be able to subtract 1 from it because it goes from 1 edit to 0 edit. So in that way, you could actually probably do something like delta total minus 1, and then delta total plus 1 plus 1. So this would probably give us the same answer, and then we don't even need this, and that's pretty much roughly the problem or the solution. Basically, the hardest part is just visualizing this problem and then converting it into a line segment intersection problem in 1D, and then it becomes a prefix sum and becomes pretty. The code is pretty clean as I kind of see it now, but it took me like a long time. I spent a long time, and then I skipped ahead to Q4, and then I come back to it. So that's why the contest is actually over now. So let me refresh, and I'm going to do a minor code review for this problem before. You can watch me solve it live during the contest as well, though that's going to take a little bit. Let me see how other people did it. So okay. So other people basically did it the way that I said it, except for they wrote much tighter code for it. So yeah. So it seems like I'm happy with my solution, or how I explained it. Alex even did the event's name. But yeah. Same idea basically. So I'm happy with my explanation. I don't know if I'm happy with my explanation. Let me know what you think about the explanation. Hit the like button. Oh man, I finished 100 in seconds. I didn't get the top 100. But anyway, yeah, let me know what you think, and you could watch me sub it live during the contest next. Let me skip ahead. Mind blank. Even then, put in the... one button. This is nonsense. Okay. And limit is 120. Okay. Why would we want to change it to 3? Okay. Well, seems like I need to do this. That took too long. Oh man, okay. Think about it. It's not finding. Okay, so I mean, it's just some sort of counting, right? So you want to get to text here. Yes, this is the case. I get how I want to do it. Get how I want to do it, but it seems hard. So we want all the keys in array such that it is the total that we want. All the numbers that are key. So like that, but it's not going to be right. Obviously, I didn't do one part of it, but it's a really hard way of doing it. But that is not right. That is not true. MS. Wait, what? I think I messed up some stuff. So we're looking with 4, then the max is less than. Okay, so I'm the thing to the above, that's good. And it's oh, and this is not n minus this is n. Oh, just n over 2. But okay, so now means that anything under that we have to do twice. So this is actually this. That's good. and then we move to double count. Well, still not right, but this gives me 0. So this is going to be 1. Why is it 1? They're all below. So above are the ones that are 1. And then we subtract it from I see. Those numbers appear twice, so well, it looks closer, but still not right. It thinks that if the answer is 3, it needs 1 move. Why? Now it tries to go for the answer 2. It's 4. We do this twice for the min as well. There must be an easier way, come on. So much time on it. Should be 2. Let me see if I can. Oh, okay. So I did get it right, except for I was stupid in one of the things. But how did I get this one then? Wow, I'm actually pretty happy with that one because but I knew I wanted to I was just careless. Okay. How did I do this one? Okay. So I have to do some sort of sliding window thing. I think, okay, let's think about it. I have half an hour. Here's a hard contest, but what is the min is? Of 1. After the upper limit, it has to do another one. Okay. No, I did something on this one because it didn't work for this example. Okay. By definition, if it should not be double counted, right? Okay, so that means that actually by definition all of this max one should be less more than total. That's dumb. Why did I do it this way? So actually I just need this to be an int. I need this. And now we go for max total. Okay. Pass is main pass and it means that that's everyone's out range, so that's 2 times n or 2, well just n. Well, worth a shot. Okay, so try all the way to 6. And this is right. That's right, I guess. No, that is not right. Oh, this is this. Okay. Still not right, but slightly better maybe. 4, 2. We want to get it to 4. And it's actually 1. Current is 4 for numbers, hits the negative 1 on 2, 3. Oh, this actually is not necessary. Well, not right either. Minus. Oh, oh, I see. That's double counted. Okay, so this is actually one. Okay. Is this right? I have 18 minutes. Why not YOLO? Well, let's double check. 4 is 1, 6. Can we get to 6? Yep, change this to 3, so I guess that's okay. This is 2 because we don't. No, because for 4 we choose. Alright, I see. This should be max plus 1. Yep, 4, 3 is 2. Okay, fine. Come on, please. Yes. Okay. That was a hard. Hey everybody. Yeah. Thanks for watching. Let me know what you think about this problem set. That was a very tough problem set. So and this problem as well. So hit the like button, hit the subscribe button, join me in Discord. Let me know what you think. Let me know your questions, and I will see y'all next problem. Bye bye.